In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. In question 4, part A, we have a complex number question. They give us this equation. It's a quadratic, but it's a complex quadratic. And they tell us one of the roots. One of the answers is this, and they basically ask us to, they don't ask us to find the other root, they ask us to find the missing letter here. So we have one of the roots, we have the equation, what's the missing letter? There's a good few ways to answer this question. The most simple though is, if this is a root, it just goes in here and everything will equal 0. So that's the most simple way to do it. I'll do another couple of ways in a moment. So if we just put this number in here, we get, we get 1 plus I squared plus 3 minus 2I multiplied by 1 plus I. So everywhere I see a z, I'm just putting this root. Plus p is equal 0. Multiply this out, we get 1 by 1 is 1. 1 by, well, let me write them all out. 1 plus 2I, we'll get I and another I. And then we'll get I squared, which is just minus 1. So I'll just quickly change that, save me a whole new line. Here we will get 3 plus 3i, this by that, minus 2i. And we will get minus 2i squared. I squared is just a minus 1, so it just becomes plus 2. Plus p equals 0. Let's clean all this up. We have a 2i and a minus 2i. We have a minus 1 and a 1. Let's see, we have 3 plus 2, that's 5. Plus 3i. Plus p equals 0. Let's rearrange that. We get p is equal minus 5 minus 3i. And that's the answer to part A. You could have done that a few different ways. We could solve the quadratic using the minus b formula. That'd be one way, way too difficult. A clever way I see when I was checking the answer is to notice that this number here is the two roots added together, or minus of this number is the two roots added together. So using that fact, we could say this root, 1 plus I, plus some other root, z2, is equal to minus this guy. Plus 2i. We could solve z2 must equal minus 4 plus I. And if once we have both roots multiplied together equals this number. So it was just a clever way to have done this. So p must equal 1 plus I multiplied by minus 4 plus I. And if we multiply this together, we get minus 4 and another minus 1 from the I squares, which is minus 5. We get I minus 4 i's, which is minus 3i. Get the same answer. That was probably the shortest way. They're both quite short ways to do it. Other ways, we could turn this into a factor, z minus this, and divide it into that. That's another complicated way. We should get the same answer anyway. Let me clean this off and we'll do part B. In part B, we're given w squared is equal to minus 1 plus square root of 3i. And we're asked to find the values for w, so we know there's more than one. We're given a big hint. We asked to use de Moivre's theorem. Now that's a formula you will find in your formula book. I won't bother writing it out. But when you look it up, you might be worried to find lots of cosines and sines and e to the power of I. So how is that related? Basically, when you're taking the power of a complex number, it's actually a lot easier to do when it's in polar form. which is what you're seeing there, the cosines and the sines. Polar form is very easy to deal with powers. So what we're going to do is we're going to change this into polar form to then get the answer. Because basically what they're asking us to do is find w. And w is equal to the square root of minus 1 plus square root 3i, which I guess is minus 1 plus square root 3i to the power of a half. Okay, so we're dealing with a power here that's not easy to do. So if you're ever asked to get the power of a complex number, and it's not an easy one to just do by hand, like to the power of 2, you can multiply it out, no problem. Power of 3, yeah, I would probably just multiply it out. To the power of 9, to the power of half, to the power of a minus something. Now we're talking, it gets a lot more difficult, and De Moivre's theorem helps us out a lot. De Moivre's theorem, any powers just turn into multiply quite easily. We'll see that in a moment. First, I need to get it into a form that De Moivre's theorem can deal with, and that's those cosines and sines. So I do that by drawing a picture. Let's draw a picture of this guy here, minus 1 plus 3i, plus, square root of 3. Square root of 3, I just need a rough picture. Square root of 3 is about 1.5, I think. So minus 1 is down here, 1.5 up here somewhere. This point, w squared is right here. What it looks like in polar form, in the form of the cosines and the sines, is I want to know how far away from the middle it is and what angle it makes with the x-axis. That's really what I want to know. So if I just deal with this triangle here, let's draw that again. This triangle, what's the length here? Remember, it went down minus 1, so it must be 1 long. What's the height? I went up to square root of 3, so it must be square root of 3 long. And this angle out here, well, if I find this angle in here, I can just calculate that one out there. So what's this length? First of all, it's a right angle triangle, just Pythagoras theorem. Square root of 3 squared is just 3. 1 squared is just 1. 3 plus 1 is 4. Square root of 4, or 2. That's the length here. That's one of the important numbers I need for polar form. I'll write it out in a moment, the polar form. This angle in here, you could use sine, cosine, tan. You have all the numbers you need. But usually we use tan because we started with these two. It's not important though. Tan of, let's call this phi. Tan of phi is equal to square root of 3 over 1. Your calculator will solve this, or your formula table. Square root of 3 is a common one to do. You can find this in your formula tables. It'll tell you that this angle here must have been, let me just double check, 60. It must have been a 60-degree angle in there. So what's this angle out here? It's 180 minus 60. That must be 120. So the angle we're dealing with is 120. We've everything we need now for polar form. Instead of this number up here, I can write that as this length, or the radius, or 2, multiplied by cosine of this angle. This angle was 120. 120 plus I sine, again this angle, 120, and that's it. Instead of this way, I can write it this way. It looks a lot longer, it looks a lot more complicated, but it's so much easier for powers because of De Moivre's theorem. So if I want to get W here, it's equal to this guy. Let me just write it again. It's going to eat up my pen, but still. Oh yeah, I'm making I guess around this point I'm making a mistake. I know I'm doing it. I'll come back and deal with it in a moment. This is all to the power of half. De Moivre's theorem then tells us this half can come in. Just normal algebra tells us this half can come in over this 2, get square root of 2. But this half deals with this cosine plus sine in a very interesting and nice way. It comes in and goes cosine a half of whatever's in here, 120, plus I, this is where I'm making a mistake by the way, I sine half of this, which is 60, And this would be the answer. We could, we're only getting one answer though, and that's a bit of an issue. I'll show you where the mistake is in a moment. But we could turn this back into a normal looking way just by putting this in calculator. Cosine of 60 multiplied by the square root of 2. Let me just check my notes here. That would get you the square root of 2 over 2, because that would be a half multiplied by the square root of 2. Plus an I, and this would be, I think, square root of 3 over 2 multiply square root of 2. Either way, it would come out as square root of 6 over 2I. That's an answer. You would get a lot of marks for that, but you are missing something there. Let me just make a little room down here. I should squeeze it all in underneath here. At this point, I made a little bit of a lie, I guess up here as well. I said 120 was this number, and that 120 came from, how do I get to this point? I go 120 and I go out 2. That was so reasonable. But what was wrong with going 360 plus another 120 and going out 2? It still would have got there. So the actual answer I should have here is 120 should be here, but also 360 more. So a very similar answer could have been 2 cosine, what's 360 more is 480 plus I sine 480, and all this to the power of a half. This would have been a perfectly okay thing to write there. Also, if I'd gone minus 360 plus 120, which would be a minus 240, that would have been okay. If I'd gone 720, gone around twice, and that would have got 840, I think. They would have been all perfectly good things to write there. Infinite. There should be infinite answers there. And usually that's not a problem, except we got half of it here. So half of 120 was 60, but half of 240, put that out here, 2 cosine 220 plus square root of 2 should be there, sine 220. While these two lines, 120 and 480, are identical. They're both the same as each other. Once I did the half, these are not the same anymore. These are two distinct answers, and if I put them in on the calculator, I would get another perfectly okay answer. Instead of this answer, I would get minus square root of 2 over 2 and minus square root of 6 over 2. So we get at least two answers, but remember there were infinite choices up here. I could stay going on for days and got half of all of them. Now at that point you would find all your answers repeat. You would only ever get two different types of answers. You can think about why, because up here we're dealing with the only answer between 0 and 360 is this. Once we half it, we would end up getting two answers between 0 and 360. If I had it divided by 3 at this point, we'd get 3 answers, so the cube root. If I divided by 4, I'd get 4 answers. I guess maybe 2 of those answers would be the same. I'm not sure. No, I don't think they would. We'd get multiple. You have to be a bit careful about that. That's hopefully I explained that. That's your final two answers for part B is this here and this here, which are just minus of both of them. In part C, we're given this drawing here with a point put on the Argon diagram of U. And they tell us U is equal, hopefully you can see that, is equal to A plus BI. So we don't know what it is. It's roughly in this spot, and we're just going to be asked to do a bit of maths with it and a bit of drawing with it. First thing we're asked to do is to write out IU. So there's U. IU is just I multiplied by that. So that's just AI plus BI squared, which is just minus B. Write it in the more normal terms is the real part first, minus B now, plus AI. That's it. Then they also ask us to to calculate IU conjugate. the complex conjugate of this one here. And that's just equal, we leave the real number alone, conjugates don't touch the real, and they just change the sign of the imaginary, minus AI. And then for part 2, they simply ask us to plot both of these on the drawing here. So with the numbers, let's see, this length here is A, this length here is A, up here is B, so this length here is B. So they're asking us to go B length to the left, minus B. So whatever length this is, you could take a compass to be exact, and you just get it down to the minus side. So that's minus B there. A, we need the A length up positive, so we need to go up A. So there's the A length, get your compass, and you go up that length. So I guess that would be A there. There's that point. That point just goes to there. I at this point I'd usually talk about what that means, but they're going to ask me in the next part to talk about that, so I'll wait a moment, I'll bite my lip. The next one, the conjugate, is minus B, so we get the minus B length again. We already have it here, it's out here, and we minus A. So instead of the A length, we're minus A down here. So that's, let's put these in, it's IU, that's IU conjugate. For the final part, they ask us to state the transformation or series of transformations that would have sent U all the way to the conjugate of IU. Right, what happened there was, when you multiplied by I, something very interesting happened. We actually rotated 90 degrees. We rotated 90 degrees. And you can see that if you stay multiplying by I. Multiply by I again, we rotated another 90 degrees. And you would end up down here. Multiply by I again, we'd rotate another 90. You'd end up here. And multiply by I again, or I to the power 4, you'd end up all the way back up here. These two are the easy ones to see. I squared, multiplying by I twice, is like multiplying by minus 1, which is like that. The real part got multiplied by minus, and the imaginary part got multiplied by minus. So we get there. Multiplying by I to the power 4 doesn't do anything. I to the power 4 is 1. So we don't do anything. So it's actually just rotating us around. And that's one of the useful things about imaginary numbers. It's really helpful at understanding rotating and stuff. Don't worry, it's not. That's not in the Leaving Cert. So we rotated 90 degrees, I guess, anti-clockwise by multiplying by I. And then what happened next is the conjugate. What the conjugate does is it only changes the sign of the imaginary part. That means it always just mirrors the x-axis, the real axis. So we just mirrored down there. Is there a better word than mirror? I can't remember. I'll let you guys correct me. Rotate through, something like that. Well, I guess not rotate, although rotate also works. A full 180 rotation. Anyway, some of the words I used would be perfect for answering that. Hopefully you can throw them together in the right way. Better than I can at least. If you have any follow-up questions, let me know in the comments. I'll do my best to answer. Thanks for watching and have a great day.